Hello and welcome to everyone. In today's video, I'll explain the connections of the 4-bit binary adder. Let's start with the IC number. It is 74LS83 and this is the IC, and you can see the number here 74LS83, and this is pin number 1, and we need to connect this IC on the test board. I already did that. This is exactly the same IC. Now before the wiring process, I want to show you the inputs and the outputs that we need for this IC. I know that we already discussed this before, but this is just to remind you how the 4-bit binary adder looks like. Let's consider that this is our 4-bit adder, and because it is called adder, that means it adds two things together. So we have a first value called A, and then we have another value called B, and each one has 4 bits. Each one consists of 4 bits. So these are the inputs, and then we have an output, and this output also consists of 4 bits. But because 4 bits might not be enough to contain the summation of two numbers, each has 4 bits, we need a carry out. So we have here 1 bit called carry out. Why do we need the carry out? Just a simple example. Let's say that we have 0, 0, 0, 1, 0, 0, 0, 1. This is A and this is B, and we need to add them. So 0, 0, 0. 1 plus 1 is equal to 0, and our carry out is 1. So if you look at this number, it is 1, 2, 4, 8. So we are adding 16 plus 16, it is equal to 32, and this is 1, 2, 4. This is the weight of each digit. 8 and, sorry, 1, 2, 4, 8, and this is, this is 8. Plus 8, it is equal to 16, and this is 16. This is the output. What I need to mention here is we need a carry out. So this is our carry out. Anyway, if you look at this box, you can understand the pins that you are going to connect to this IC. So for example, we should have 4 pins for A, another 4 pins for B, another 4 pins for the output, and 1 pin for the carry out. Also, we should have ground, VCC, and we might need another pins like clock. We don't need clock in the ALU, but if you remember in the previous video in which we explained the registers, we needed a clock. Anyway, if you understand this, then you will be able to understand this IC. I hope that I have a large picture here. Yeah, I have another one here. So this is how it looks like. This is exactly the same picture, but here it is a little large so you can see. Where are the A and B values? First of all, you can see that we have A here, right? So this is A1, A2, A3, and where is A4? A4, okay? I know that in real life we don't have pins here and here, right? We don't have pins here and here, but theoretically they add the pins here and here. But you can know the numbers of the pins from here. This is pin number 1, which means it is this one here, this one, okay? Anyway, I don't know why they didn't put, for example, A here, B here, and the output is here and here. I don't know why they organized it like this. But anyway, we are going to deal with it, okay? So not everything is clear in this picture. So for example, the VCC is on pin number 5. The ground is on pin number 12, so this is the ground, and that is what we need to connect. So do you remember how can we represent A and B in hardware? We already discussed this, I mean like literally in each video. So we can represent A and B by switches. So we have here two boxes, each one has 4 bits or 4 switches. That is A and B, and I'm not going to explain the connections of these switches because I explained this like 4 or 5 times in the previous videos. This is for A and B. I didn't connect A and B with the IC. I'm going to do this right now. Then we should have 4 bits for the output. And how can we represent the output and also the carry out? By LEDs, right? By the LEDs. So let's start connecting A and B. I am going to say, let's consider this is A and this is B. So I have here some wires. I have A will be connected by the green wires, and B will use the red wires. I already prepared them before starting the video. So let's start here. But before starting the connection, I need you to make sure that you organized the connections correctly. What do I mean here by this? So let's say that this is A1, A2, A3, A4. So this is A. And this is A, right? So you should say that this is pin A1, this is A2, A3, A4. You cannot connect this one to A1, this one to A2. You are going to reverse the connections, okay? In all binary systems, we know that this should be bit 0, this is bit 1, bit 3, bit 4. You cannot say that this is bit 0, okay? Because this has, each one has different weights. This is 1, 2, 4, 8, okay? So what I need you to pay attention is this connection, because when we go back to B, it is gonna be different. So I already did this mistake, and that's why I am telling you that. Anyway, let's start now. We need to start with the first pin, and this pin should be connected to A1. Let's look at A1. Do you see A1? It is at pin number 10. So where is pin number 10? Let's say that this is 1 to 8, this is 9, and this is 10, okay? So I am going, we can do some zooming like this. Okay. Now I am going to say, let's start by connecting this pin number 10 to pin number to the first switch here, first switch on the right. Now we need to connect this pin to A2. So where is A2 here? Let's see. Yeah, A2 is it is in pin number 8. So we need to bring something from pin 2 to pin number 8. This pin to pin number 3. Where is pin number 3? It is A3 is on pin number 3. So I am going to say pin number 3. Yeah, it should be this line. And finally, A4. Where is A4? I'm not sure if A3 is here, okay? Where is A4? A4 is pin number 1. So we need pin number 1 here. This should be connected to pin number 1. So we finished the connections of A. Let's go to B. So let's start with this pin, right? Is that right? No. Usually by default you will start with this pin because this is the first one on the left and it is the closest one to the IC. I need you to start with the pin on the right because this is bit number 0. So I am going to connect this one to B1. Where is B1? B1, yeah, B1, pin number 11. So I'm going to come here to this pin 11 here to the first bit here. Okay, then let's take bit 1 here to B2. Where is B2? This is B2, pin number 7. So this should be pin number 7, this one. And then B3, it is pin number 4. So pin number 4, so from here to pin number 4. The last bit here to B4, where is B4 here? B3, B4, pin number 16. Pin number 16, this one, to bit 4. Okay, so now we finished B. We need now to connect the output. So we have some LEDs here. I hope that you can see them. We need to start connecting them. So let's start with output, the first output, which is E1. E1, this is on pin number 9. So I'm going to do something. I'm going to just make a connection from pin number 9 to this pin here. Do you see this pin, this one? And then I'll connect this LED. Do you see the LED? This is the positive part and this is the negative part. So use the positive part here and the negative part here. So this is bit number 0, which is represented by E1. E2 is pin number 6, so I'm going to connect pin number 6. So this is 8, 7, 6 here. Yeah. And then E3, pin number 2. So this is pin number 2 to the ground. Pin number 2 to the ground. And finally E4, where is E4? E4, pin number 15. So let's do another connection, pin number 15 to this one. I am doing this connection so I can make them, all of them in one line. Not because without these two connections, we will have 2 LEDs here and another 2 here. So I need to see digit 0, digit 1, digit 2, and so on. Anyway, let's connect this one. What else do we have? We should have also the carry out. The carry out will be C4, not C0. So let's connect this to the last LED. So this is pin number 14. So I'm going to do this pin number 14, and this is gonna be the carry out. So let's now connect the VCC and the ground. So ground on pin number 12. So pin number 12, let's say this is 9, 10, 11, 12. So this is 12. Also, we have another pin called C0. This should be connected to the ground. You should look at the specifications to to understand it, but anyway, it is the carry n, which is, if you remember, for the 4-bit adder, we should see a carry n here, cn here. This is our carry n. I don't want to start with using carry n equal to 1. I need to use it equal to 0. So I'm going to connect this also to the ground. So let's connect this pin also to the ground. It is pin number, let's see, pin number 13. What else do we need here? I think we can start now. This is our power supply. This is the green is positive and the blue is negative. And now we have everything working. But these are ones, these are zeros. We should see some values here. So something is not correct. What we are going to do is we are going to start checking the power supply. By the way, I don't know the problem here. I'm going to investigate the problem with you. So I don't know why this is working now. It was not working before. Let's start. Let's do this. Okay. This is our voltage. Yeah, we didn't connect the VCC and the ground. I told you that we need to do that, but we didn't do it. So I'm going to remove this. We need the ground. We already connected the ground. We need the VCC to pin number 5. So where is pin number 5? 1, 2, 3, 4, 5. So pin number 5 to the VCC. Yeah, let's start the connections again. Yeah, it works fine. Okay, so now I start with everything is 0. A has zeros and B has zeros. Okay, let's start with 1. I am adding 1 to 0, right? So let's also use 2. This is 2, and then 4, it is 4. 8, it is 8. Okay, let's check A also. So 1, 2, 4, 8. Let's add some from here and some from here. This is 1, okay? So this is 1 and 1. The output is 2. 1 and 2, it is 3. 1 and 4, it is 5. 1 and 8, it is 9, right? Let's do this. 3. So let's say 2 instead of 3. So 2 plus 1, 3. 2 plus 2, 4. 2 plus 4, it is 6. 2 plus 8, it is 12. Let's start using like this. 7 plus 1, it is 8. 8 plus 2, it should be 10. Yeah, 10, 8, and 2. And then plus this one, so 7 plus 7, it should be 14. 14 is 8 plus 6 plus 8 plus 6, it is 14, right? So do we have something wrong here? I'm not sure. Let me see. It should be 8 plus 6 plus 2. This is 16, not 14. So 7 plus 7, yeah, it should be 14. I don't know why this LED is lighting not correctly. But anyway, let's say 7. So 7 works fine. 7 plus 1, it is 8. And then, okay, let's say 7 plus 2. 7 plus 2, it is 9, so 8 and 1. Okay, that is good. 7 plus 8 plus 4, it is 11, so 8 and 3. So 11, put 1, so it is 12. 12 now, put 2. Yeah, it works fine. Okay, so this is how it works, but now we need to test the carry out. So I'm going to add this. As you see, the carry out also works, and that is all we need to do. Now I want to summarize what we did today. Let me show you a very important picture here. Where is this picture? One moment. Yeah, it is here. In the previous video, we discussed how to connect the registers. Okay, let me remove this. I explained how to connect the register, and this is our register from the previous video. So this is R1. I am going to do the same for R2, and today we explain the ALU. By the way, in the next videos I'm not going to use the carry out. So because the carry out will make this 5 bits and our bus will be 4 bits, and if we do 5 bits it is gonna be a little complex, and I want to make this easy for you so that you can implement it yourself. So we finished this part here, this area here. What we need to do is this area, this line. So we need to connect the bus in order to make the ALU and the R1 can do the operation, the add operation or the subtract operation through the bus. By the way, we need to add another operation, which is the subtraction. So I'm going to explain how to do subtraction also.